you ready for me to go? Okay, here we go. Basically, my history is kind of tethered with coastal processes, and I'm going to give you some background and show you how, it's sort of a collective learning process. If you have a base and you have a strong foundation, you can go, kind of learn any aspect of the past. But today's goal, like Dr. Speed indicated, it was primarily centered around coastal erosion. And of course, my background, I'm a little bit further to the south in the central Chesapeake Bay. I grew up on an island in the middle of the Chesapeake Bay and a fishing community. So needless to say, I paid my way through college by working on the water in the Chesapeake Bay. And anyhow, my father kind of instilled a lot of interest because there wasn't really much to do on an island to entertain yourself during the doldrums of the winter. And he kind of, as a kid, did the same thing, walked shorelines and collected material. There was an island just south of Tillman Island, that's where I grew up, that had existed for, since the 17th century. But he, as a kid, and there's a picture of a kind of a red arrow pointing to him in 1938 on the island, would go regularly visit that island and collect artifacts that had been displaced as a byproduct of coastal erosion. Ultimately, they were able to amass over 16,000 projectile points, and that's just the complete ones, not the broken ones. And they span 13,000 years of human prehistory. Just to give you an idea of the dynamic nature of erosion, Sharp's Island as an example, this is a historically documented loss of land. In 1608, John Smith could not see the mouth of the Chesapeake Bay when he explored the Chesapeake Bay during the Virginia colony initial settlement. By 1670, the island had been reduced to about 1,100 acres. The first deed for the plat was around 1,400 acres, and that was in about 1640. So erosion had occurred. By 1900, it was only 98 acres. So a net loss of over 1,000 acres of land during this duration. There were hotels, there were people that lived out there, were farms, and they all ultimately succumbed to erosion. So my father sort of collected the material, the tailing, so to speak, of the leftover. In the winter of 1977, unbeknownst to my knowledge, I actually found my first fluted point, but at the time I had no idea what it was. The winter of 1977 was a particularly harsh winter. The Chesapeake Bay froze solid with ice about 2.5 foot thick. And as a result, we had nothing else to do, so we basically walked the shorelines of the island. Once I realized what I had been finding, I started to plot everything. I was kind of an anal kid, and I recorded the locations of where I would find Clovis points or fluted points in general, and any diagnostic artifacts. And this is me taking pictures and plotting the locations of artifacts. And then in 1987, I attended a conference at the Smithsonian. Being a shy kid otherwise, this was the location where I first met Dennis Stanford. And I took a bunch of artifacts that I had found. I figured since it was origins, I would take some objects that might interest him. And he took time out of his schedule to look at this material. And he immediately said, hey, when can we come over and look at these things? Which was kind of radical for me because at the time I really could get no traction anywhere. And when he came over, he brought a ton of people: George Frizen, Vance Haynes, you name it, all the biggies and the Western Paleo-Indian interest. And Vance Haynes was the first one to really date a surface that we would later call our Tillman soil. And he collected a sample and during that initial visit and produced a date of 17,820, which calibrated to a little over 20,000 years. Interestingly enough, we've kind of puzzled by this, but that was probably a very good date for that surface, and we'll get to that. Dennis, being true to his word, said, hey, let's go out and do some excavations. So in the following year, they came and we did some excavations. This is the nice day, which was a Saturday. That night, it blew a gale out of the northwest, and all of our 4 test units got backfilled just by wind. Literally, we went there the next day, and you would never know we had dug anything. And we had some fairly decent deep holes at that time. It just goes to show you that wind is a component of this landscape and the site formation processes, which we will get to. Um, and again, after he left, I was kind of progressing in my academic interests. Anyhow, we did some initial testing in 1989, looking at the soils. And this is a fluted point we found in the block bulk sample as we're digging a hole trying to look at the geology there. And then we did some later work there the following year and found some more artifacts in situ. And then in 1992, after completing my degree, I spent the summer excavating there and siring generations of biting insects as well. And as a result, we did find some additional material in situ, but it was buried. It was deeply down. I say deep, 50, 60, 70 centimeters, depending on where we were. And then in 1999, we did some additional follow-up work further to the south at another location where we had found some material along the shoreline. Here's the fluted point we found in excavation. I appropriately changed the sign at the entrance to the driveway to reflect its antiquity, circa 11,000 years BC. But one thing that we learned during that initial test there is that we had early Holocene occupation pretty much confined to the plow zone or the base of the plow zone. And the Paleo-Indian material was separated by wind-blown silts, loess, and the artifacts were lying on top of this surface that, based on Van Haynes's date, was somewhere on the order of 17,000 years old. So we were like, no, well, maybe his date was wrong. We approached it from that perspective. However, what was the origin of this loess? We could confine it using the archaeology to this interval. This is the Northern Hemisphere ice core record. And it correlates beautifully with the Younger Dryas, a return to almost full glacial conditions or near full glacial conditions. So we could compartmentalize the age of it just based on the archaeology. So our perception was, okay, there must have been some severe dust storms during that interval between, say, 12,007 and 11,006. Over the years, I amassed data from various sites. Not all of these were fluted points that were found by me. There were some local guys that had found a few. But basically, looking at the island the way it is, it's an upland. It's a remnant upland that has been affected by long-term sea level rise. And more importantly, where these sites are located are near the interfluves or the drainage divides. So we're only seeing part of the settlement pattern. However, this is the density of Paleo-Indian fluted points in this small little area here. These would be classified as Clovis if you found them in the American West or in the plains. And you can see there's a fair number. Interestingly enough, I started to record all these things throughout the region. Now, had I not grown up in Talbot County, that's the county I grew up in, the island, the only fluted point that would have been recorded would be this one on Poplar Island, and it was recorded none other by Ralph Solecki in 1960 in an issue of American Antiquity, Poplar Island and Changing Sea Levels. So if when you think of the circumstances here, the recordation and the documentation of any artifact, be it Paleo-Indian or later, is just a byproduct of circumstance. And again, had I not been born there, you only have one triangle as opposed to 50 fluted points for that small little area. And this gets to the crutch of my sort of issue, or what I want to portray, is that when you're dealing with the coastal plain, or like the Chesapeake Bay, you've got various processes, not just the human recordation process, but you've got the sea level rise component, which is a long-term time component. This is what you've lost, basically. This is what the Chesapeake Bay looks like today. And you also have historical erosion, which I just talked about. There could have been oodles of Paleo-Indian sites or any other sites, but they have succumbed to coastal erosion before SHPO offices ever existed. And many islands in the Chesapeake Bay disappeared well before the 1960s. And this is a great example. And then you also have recent erosion. This is just documenting one of the islands on the northern end of in Dorchester County over a period of time. And then more importantly, there could be some amazing sites here, but you can see what ultimately is going to happen to them. They're going to disappear. And if nobody's out there recording them, then bottom line is no triangle gets on the map. Then in 1999 to 2010, the Commonwealth of Virginia gave me the opportunity to move further south and to educate myself in a different region of the Chesapeake Bay. And it is different in many respects. And I'll show you sort of collectively short what we learned there. Um, this is, oh, my screen is kind of weird, wonky here now. This is basically the northern end of Virginia, northwestern end of Virginia. And these triangles represent Paleo-Indian points, not all of them Clovis points. There's 23 here. And again, had I not gone there and started to talk to people and record stuff, this would be the only point that would be recorded for that region. And it was recorded by none other than this guy, who was Junius Bird, who had worked ironically at Fells Cave. And he went on vacation to Tangier Island and happened to record a fluted point on Tangier Island, which is now at the American Museum of Natural History in New York City. And I'm going to focus on this island called Watts Island because it's a federally owned island. It's owned by the U.S. Fish and Wildlife Service and managed under them. I surveyed initially Watts Island in 1999 when it was privately owned, and Watts Island has been constantly eroding. And these are some of the fluted points that locals have found, just a few examples. But it should be blatantly obvious of the process. If you look at what happens every year, the U.S. Fish and Wildlife go out and stick signs saying no trespassing, bird nesting area. And within months, the signs have all been dislodged because of coastal erosion. Just to put this in perspective, in 1999, when I first visited Watts Island, the shoreline was up. If you look to the right, you can see where the shoreline was in 1999. That was 1,993 feet further north of the existing island. This is a photograph that I took in 1999 at an amazing site, actually. It was just littered with artifacts, some of which are early Holocene. I don't think we ever found a Paleo-Indian point there. But you can see on here on the left side, just a short interval of about 4 years. This is the southern end of Watts Island. Basically, what I've been able to document is this process. Here it is in 99. There were 6 sites. Here it is in 2013. 3 of them are still extant. And based on recent erosion, there's only 2 left. So bottom line is going, gone, if you can relate to that. And there is a dislodged Paleo-Indian point there on Lewis. It's not in situ, it's in secondary deposits. Then I also moved further down the bay. This is near its mouth, a place called Savage Neck. Savage Neck is loaded with archaeological sites. Most of them, unfortunately, are hidden by this gigantic late Holocene dune, which blew up sometime in the last 1,000 years. But you can look on the right-hand side, really and truly, the shoreline hasn't changed much there. Even though the fetch distances are massive, there's so much sand there that it actually acts as a breakwater. It impedes coastal erosion. Unfortunately for the site, but fortunately for me, a landowner to the north decided to construct a seawall in 2009. And I told my wife at the time when we were walking down there, I said, he's going to regret that because that's going to change the whole dynamics of sediment movement. And that's exactly what happened. And thus, underneath of that dune, you could see the old landscape. In some cases, this dune is 64 feet in elevation. So there's 64 feet of Holocene sand covering over 1,000 AD land surface. And then beneath that is even a deeper material. And that red arrow is going to show you what that was. This was after a tornado went across the region. And you can see that point. I don't know whether you can see it here. There it is right there. It's 80 centimeters beneath the 1,000 AD surface, buried by wind-blown silt, yet again analogous to what we see in the upper bay, wind-blown silts capping over Clovis occupation. And this site, other people have found Paleo-Indian points. The only one I found is the one on the left. The rest of these, and there's like 10 or so that have been found there just by people haphazardly walking along the beach. So you can get an idea of what you wouldn't know. And most of pretty much all of these fluid points were found after 2009. In other words, when the landowner changed the dynamics, it induced erosion. That erosion component exposed the landscape that was otherwise hidden. And bada boom, bada bang, you've got a Paleo-Indian presence that would otherwise be hidden. And this is sort of the profile in general. And the windblown silts that cap that are probably analogous to our younger Dryas Lewis, even though we don't have early Holocene stuff there. Based on the soil development sequence, the early Holocene would be material would probably be near that 1000 AD surface. So we have a common site formation process further up the bay as we do in the lower bay. And then in 2001, I moved over on the seacoast, Virginia. This island is absolutely amazing. I've never seen a landscape my entire life loaded with so much stuff. To give you perspective, because I remember my father telling me as a kid, you know, that when he first went to Sharps Island, there was this stuff everywhere. There was a site, an area geologically and based on the soils. It should have been amazing on the east side of Mockhorn Island. It took me about 6 trips to finally get there. And we got there on October 13th, 2001. And when we landed there, the best way to describe it is if somebody went to the Smithsonian, got the Middle Atlantic collections and dumped them. In 2 hours, we found 758 diagnostic projectile points, including 3 fluted points. There's quite literally thousands of items there, and it spans everything from Clovis all the way up to the late Middle Woodland, Jack's Reef. The Jack's Reef component there is the most, but this is the site we're going to focus on, 44 and H233. Eroding. There had been a Paleoindian point recorded there prior to my visit to the island, and this illustrates one that we found. You can see the erosion on the west side, and you can find scattered artifacts all in the intertidal zone. And then sometime around 2009, 2010, the state of Virginia or Commonwealth of Virginia and the Smithsonian funded a project where we were going to go and excavate the site and map every artifact in the swash and berm zone, and then understand basically how sites are torn apart by coastal erosion. And it was actually an interesting sort of process because everybody found diagnostic, or at least somewhat diagnostic, Paleoindian artifacts. This is a broken basal end of a Clovis point. It's missing its barb and tip. And interestingly enough, this is Dr. Peggy Jodry of the Smithsonian. All these red flags represent artifacts. Here's Mike Frank, who worked at this Paleoindian paleoecology program. And then the basal end in the lower right is the first Clovis point Dennis Stanford ever found east of the Mississippi. He found that on this island. And then we were there at the right time. You know, I was doing excavations. You can see the excavation units, and we mapped all these artifacts. Those red crosses. But we were there before Hurricane Sandy, and then we immediately went after Hurricane Sandy. And what was interesting is you can see how wave energy and the storm surge transgress those artifacts, because basically all the artifacts that were in the area where the red X's are disappeared. They were gone in one storm. And then we moved inland another 80 meters or 40 meters or so, and lo and behold, there they were on top of storm surge berm. And the artifacts had transgressed that far in one event, which was interesting to map and record, but we could actually see how wave and storm surge processes affect the transgression of artifacts. The site, the actual primary context site, is actually underwater at high tide, and that's illustrated to the left. And then those artifacts get plucked out by wave energy. They get moved inland towards the intertidal high tide mark. And then when you have a storm come along, like Hurricane Sandy, they move even further inland. And this was a great opportunity to understand, you know, how sites are torn apart, if that makes any sense. It was a logistical nightmare excavating there because you had to time it so that the tide was low midday. So you had to go out in the morning, wait for the tide to fall, and you could put in one test unit at a time. And the reason why you didn't want to put many is because within one tidal cycle, your test units would wash away. And that's what you're seeing in the lower right-hand image. And then there's an in situ artifact in the upper right-hand portion of the image. What was cool about this site is that it looked so totally different than a lot of the other sites. First of all, the fluted points on the lower end of the peninsula, where there is virtually no high-quality cryptocrystalline material as cobbles, are generally big, much bigger than you'll see anywhere further up the bay. And there were a lot of PSSKA, and there were actually chipstone adzes. This is one here made out of quartzite. We found a couple of these kind of potato-sized pieces of, they look like a round baked potato, but they were quartzite, and one end had been oxidized. The other end had some black organic gunk on it, which you can see in the scanning electron microscope here. And when they did the analysis of that, they noticed a peak in copper. Well, you don't have copper in the coastal plain. And basically, through the analysis, we've determined that it's white birch pitch. And given all the PSSKA and the ADS, this site might actually be an example of a Clovis age, this is what was postulated. That they might have been building birch bark canoes. Who knows? But it is so unlike any of the other sites. I mean, you could go there today and probably find a 5-gallon bucket full of PSSKA. That's how common they are there. So maybe at this site, you're seeing indirect evidence of birch bark canoe manufacture 13,000 years ago. These canoes would have been an essential means of transportation in a region associated with the developing Chesapeake Bay. Fortunately for me, they cored across the bay when they constructed the Chesapeake Bay Bridge tunnel. And underneath this little island called Fisherman's Island, which is not that far from Mockhorn Island, the base of the paleo channel is about 54 meters. If you look at the sea level curve at the time, there would have been about a 7-foot developing estuary here. So maybe these paleo Indians are down there on the lower end of the peninsula because there's a developing estuary. We'll never know because most of that landscape is now drowned. But more importantly, the Paleo Indian points, which are 53 here, actually there's 2 more we could add, there's 55 in total. They're generally big. They're much bigger than anywhere else up the peninsula. So maybe that's the reason why we're there. They did have a core in this tunnel sequence that they did that produced peat that actually had birch in it at 13,488. So there were birch trees growing, maybe a little bit early Clovis or thereabouts. So in 2006, while doing a cultural resource management mitigation project in near St. Michael's, Maryland, John Waugh, who's a colleague of mine and soil scientist, we were doing some profile analysis and we came across a rock at the base of what we call our Paleosol surface that Vance Haynes had dated earlier to around 20,000 calibrated. And I'm like, how'd this rock get there? Because there's windblown loess beneath it. There's windblown loess above it. If Clovis folks were here, they would be right at that contact between the basal loess there, the upper loess. This was deeper down. So I called Dennis Stanford. He came on out and he gave it a 2 thumbs up. We excavated around that thing. We found a wedge, a couple quartzite blade-like flake, and a few other baubles there. This is the assemblage from that site. It was a very small component there. There was a little spring close by that had been buried by loess. And this is the assemblage. You wouldn't call this Clovis. I don't know what you would call it if you found it on the surface, but the point being is there are little blade cores. There's a fractured biface that they were using like a burin. There's one lancelet point and an exhausted core. The problem we had at Miles Point is like we're scratching our head. Every time we dated the thing, we came up with an even more erroneous date or a date that made us go like, wow, these people are going to think we're nuts. If you look at the dates, they span about 7,000 years, starting at 21,000 radiocarbon years, which would be very early, back to 27. Now, when we were trying to get enough charcoal to date, we were teasing out little flecks to get enough to send to a lab. And indirectly, we may have been mixing charcoal, and we didn't know at the time because we didn't have any perspective on that. But I cannot think for the life of me, and we had so many debates out there, where can you have 7,000 years of organic carbon confined to 19 centimeter thick profile? And I can't think of a modern analog to it, but ultimately we were able to answer that question. This is Miles Point. It looks like it's like double vision, but based on our understanding at Paw Paw Cove and then the dates that we had gotten, there's about 12,300 years missing between these 2 packages. Gone, not there. So in 2007, we began a process of trying to find a spot or spots where this missing layer was present or something. Something caused this landscape to be eroded. And then more importantly, if this land state was continuously a surface from 25 to 13, where's the 13,000-year-old, where's the 15,000-year-old carbon? We couldn't find it. We couldn't find it if we bribed a laboratory like Direct AMS or Beta Analytic. However, we proposed to go in and do some excavations there with the landowner at the time, but unfortunately it was entangled in a, shall we say, a cultural resource management boondoggle. And anyhow, we submitted the report, and the powers that be in the state said this construction of a riprap will stabilize the shoreline and preserve the site, and therefore there's no reason to do any additional follow-up work. So our ability to go back to Miles Point was pretty much taken away by this letter. The problem with this letter is that when they reviewed the report and they had the permit, they were going to pass the permit or at least approve of the permit to stabilize the shoreline. They didn't ask one question, and this is the most important question. How long is it going to be between the issuance of the permit and when you install the shoreline stabilization? They never asked that. It took about 4 years for them to implement that. And during that 4-year process, basically the shoreline there at Miles Point receded anywhere between 23 and 10 meters. So even though the stabilization was going to preserve the archaeological site, the delay of 4 years caused the site to essentially erode away. So if anything, the Miles Point situation should illustrate to cultural resource managers that the immediacy of dealing with these things, the shoreline doesn't stop eroding just because the permitting agency says, yeah, we give it a thumbs up and you can stabilize it. That's not what nature does. And so the point being is, this is once it was stabilized. You can see the red line there in the upper right-hand corner. It actually extended beyond the 2007 shoreline. It looks nice, but how much of the site disappeared, we'll never know. So this also gets to another issue and the legalities of dealing with coastal erosion. Maryland's a mean high tide state. Some states are mean low tide. Mean high tide means that they claim ownership up to mean high tide, which is kind of argued where that is. It also, the state of Maryland's unique. They have the critical areas laws, which says it controls land disturbance within 200 feet of the shoreline. So when you look at these pictures, what is the biggest land disturbing agent? It is the Chesapeake Bay, which is owned and managed and under the jurisdictional control of the state of Maryland. So I just throw this out as sort of a legal conundrum. So anyhow, Miles Point left us with a bunch of questions. And where do we go next? So, I did oodles of surveys. We did lots and lots of dating. We did find lots of this pulpulus. It's everywhere. We also noted this unconformity is present throughout the region, varying thickness. The thickest we ever found, it was about a meter. There are places where it's just 10 centimeters thick beneath the plow zone. But more importantly, it's everywhere, at least on the west side of the peninsula. So what's the origin of this loess? There were some colleagues of mine that deal with CRM and saying, oh, it clearly didn't blow off the Laurentide ice sheet, because the Laurentide ice sheet's way in Canada. Fortunately for me, there was a French research vessel that came up the Chesapeake Bay in 2003, and they cored the whole length of the bay all the way up to just about Annapolis, not quite there, but just about Annapolis. And in the cores that they extracted, there were hidden gems. One core here, which was near the Paleo Channel, they did find this unconformity. They found twigs and leaves. This is the radiocarbon data. It calibrates to 12,750. So we have 12,750 organics lying on top of Miocene 15 million year old stuff. So that's an unconformity. That's a major unconformity. And then further to the south, they found in another core, they found over 28 feet of silt bracketed by the dates of around 12,003 and 12,007, and they still didn't hit the bottom of what would have been the Susquehanna at that time. So there's your parent material. There's lots of silt in this valley, bracketed by 12,3 and 12,7, thereabouts. So you've got the parent material there. All it requires is it being dry and a lot of wind, and it can blow into the upland. So basically, what we have come to realize is that most of the upland buried Clovis sites are nothing more than lag deposits. In other words, the landscape got truncated so much that the heavier fraction, i.e. the artifacts, lie unconformably on something that they're not even affiliated with. The other thing is that presuming that some of these later fluted point styles are indeed affiliated with the younger Dryas, they seem to be more common on the Delaware side of the peninsula than the Maryland side. So maybe wind and dust is not a good place to be. So as a result, everybody went to Delaware. And there aren't that many post-Clovis fluted points on the Delmarva compared to Clovis points. So after Miles Point, we dated other locations. This is Smithsonian Environmental Research Center. You look at the date on that, when you calibrate it, it's a little bit older than the one from that Vance Haynes got, but it's about the same age. And there's your list package, and there's a late woodland shell midden on top that's been chopped up by a plow. We went to other localities, Barnstable Hill. This is just a few examples, and we found the same sequence. So this one we dated the humates as well. But when we were going to Barnstable Hill, we went right by a little island called Parsons Island, which you can see in the lower end. And I said to the guys, this is Dan Wagner, John Waugh, I said, it's been a long time since I've been to Parsons Island. Maybe we should stop there sometime. And that's exactly what we did. But just to give you an idea about Parsons Island, it wasn't always an island. 1650, it was a neck called Parsons Neck. It was around 340 acres. In 1992, it's only 99.1 acres, and it's now an island. It's not a neck, and you can see the historic map here that shows it as Parsons Point. This photograph, I never forget this. This is day one. We haven't even gotten to the island. And John Waugh and I were sitting on the bow of the boat, and I said, good God Almighty, we have hit the mother lode. Because from this distance, we could actually see that paleosol. And you have to squint, but you'll see it up close. I'll show you that. And it actually became our Rosetta Stone, and it filled in some of the gaps. It's like getting the Cliff Note version of a book. Now we got a few more chapters than we had beforehand. Like many exposed unconsolidated landscapes adjacent to Chesapeake Bay, it has lost land. In 1847, it was 198 acres, and in 2020, it's down to 68.1 acres. It loses about an acre a year, or at least in the last 40 years it has. This is day one. When we landed, that's no doubt what you can see there. There's a beautiful paleosol, and it's deeper. It's deeper than we had ever seen before. So what made the island so interesting was this presence of these deeply buried paleosol and sols, because there's multiple paleosols there, and the thickness of the overlying aeolian package. And there was a package of aeolian material beneath our younger Dryas and this older surface. So we suddenly shifted gears. This is where we're going to figure this stuff out, or at least. And with respect to the paleosols, in some areas, there was only one thick one. In other areas, and that would be kind of analogous to what we had at Miles Point. In other areas, you can see little layers of them with little cambic horizons in between. And we got excited about that. Are they the same age or are they different? Along the bank profile, you can see evidence of what you call isostatic distortions to the landscape, much like if you buckle up a piece of cardboard and then you buckle it down. You see folded fabric and you see pop down tension wedges. And presumably what they're telling you is that those sediments were deposited when the landscape was buckled up, when the Laurentide ice sheet was up in northern New Jersey. And that's exactly what we've interpreted that to be. So you have isostatic uplift, the Laurentide melts, delay, and then you have isostatic depression. So what about the buried paleosols? First of all, there is that missing deposit. There are lots of what we call unconformities in between, these layers are very strata. And these unconformities either represent short-term unconformities where the wind velocity changes, or they could be long-term unconformities. And you can see that in the particle size description to the left-hand side. We looked at the loess there at Parsons Island, and you could see microflex of mica. Mica doesn't It weathers pretty quickly, but we can also tell something about the source. When the Susquehanna comes from the Piedmont into the coastal plain, it goes through a big geologic exposure of micaceous schist, and presumably that eroded down into the Susquehanna Paleochannel, and then the wind picks it up and it blows from the Susquehanna eastward and forms this loess deposit. And had that loess been weathered on the surface for some period of time, that mica would have disappeared pretty quickly, but it's there. So it gives us more insights as to the point of origin. The sand there, though, which there's, Parsons has got a sandier component to it, which we hadn't picked up on before. The sands are being derived from low sea stand exposures of ancient paleochannels. There's a paleochannel that went right straight to the east of Parsons Island, and presumably one to the west, following the extant Chesapeake Bay. And the sand is being derived from local sources. So when the wind velocity cranks up, the loess is probably being deposited in Delaware because it's a finer fraction. Meanwhile, the sands are staying in more local areas because they're not going to saltate all the way to Delaware. Then a few months later, like 4 months later, we found our first artifact in situ, and I happen to have a cast of it right here. That's that guy. Or girl, I'm not quite sure gender of the artifact. But anyhow, we teased out samples of charcoal. These were big enough to date individual flecks, unlike what we had at Miles Point, where we're trying to tease up enough flecks to get a singular date. The date on that was 20,761. That's using the current Incal 21, I guess it is. And that's the current recalibration of that date. And we're like, well, at least we're getting younger than what we had at Miles Point. And then a few months later, another artifact came out. Now, this one didn't have any charcoal with it, but it's still in the upper layer of that initial paleosol, what we call our 4AB1. And as the shoreline receded, we were finding stuff along the bank profile, out of context. We found a few in the PEDs, the eroded PEDs. Here's one here. This is a blade-like flake tool in situ. We removed it in block, took it to the Smithsonian, did all sorts of weird stuff with it you couldn't do with an artifact. You could actually see the clay skins on it, which would be a subtle indication that it's ancient. And then more importantly, using X-ray, you could actually see the retouch on the backside of the artifact, even though it's still in its block matrix. And you can see something about the structure. It's subangular blocky. In 2017, we did a series. We realized that some portion of the sites eroded away and we hadn't found all the artifacts. So we went out there and we dredged, did a control dredging of the adjacent shoreline there. We found 63 flakes and or one flake tool. These are the small fraction that you wouldn't see in a bank profile, but we collected all those. We don't have as accurate provenience on them as we would like. And then later in 2017, March of 2017, the Smithsonian went out there and established two series of units along the bank face with the intention of looking, so, okay, can we find anything in this bank exposure? And the Smithsonian excavations, they found one in situ quartz flake in the 4AB1 horizon. And guess what it dated to? They found a fleck of charcoal with it. And here it is. Here's Bruce Bradley and some folks from Juniata College and the film crew filming it, and they're mapping it in. Here's the massive artifact, one little teeny tiny quartz flake, but they didn't find anything above it. And the date on that was 22,501 plus minus 155 years. More importantly, and I show you the pictures in the upper left-hand corner, those units were established along the bank edge, and in 2017, that's what their location was. By 2019, you can see how much the shoreline had receded beyond that. So we're able to document the rate of erosion and the loss of the site just by that overlaying and recording all these locations. And they also, Dennis Stanford actually found a bipointed biface on March 10th. It was a really low tide, and I called him up. I was home. I avoided it like the plague out there, but I said, go on out, walk the shoreline, see what you find. And sure enough, he found the bipointed biface, made of quartz also, in the lower right-hand corner. Hold on here. Okay. 4 months later, as the shoreline eroded, the units were all eroded away. Here's a bipointed biface in situ, large chunk of fleck of charcoal. We submitted that to direct AMS for a rate date, and the date came 22,175 plus or minus 235 cal years BP. Okay. Then we brought in Jim Feathers and Chris Moore. This was early before the SAAs in Washington, D.C. We had arranged to take them out there to collect samples above that surface to run OSL dates. There are some issues with OSL dates, but we figured we'd do it, why not, And during the SAAs, we had a crew of folks that were interested. That would have liked to have gone out. So we lined up a boat, a couple boats, and ferried them out there. It wasn't the best conditions. Matter of fact, it was blowing a gale out of the southeast, but we got them there. But you can see the OSL sampling location off to in this picture right above Mike Falt's head. And then ultimately, we visited the site 93 times over a period of 7 years, collected everything, piece plotted or point plotted most of the items, not all, but most of the items. I'd say probably 80% at least. But we're able to document when you find stuff and when you don't. And like most of the sites, when you first find a site, you find most of your artifacts first, and you can see that in this graphic at the bottom. And then as you go on, they peter down. So you're exhausting the reserves of displaced artifacts. And then here we come along dredging, and boom, that goes way up, and then ultimately the totals go down again. But more importantly, if you look at those red dots, those are the discoveries of bipointed bifaces like these. And it's almost like there's two packages. There's an early discovery and then a later discovery. But then at the top of this graphic, we've correlated that to periods of either cyclonic storms or ice. And it seems like, believe it or not, it's not the tropical storms or the hurricanes that erode the shoreline. It's the presence of ice that is the most destructive to these sites. And then by piece plotting all those artifacts, this is the distribution of 7 years of collective longitude and latitudes being plotted on a 2019 image of the shoreline. And you can see these are the good artifacts, not the debitage, but I did that as well. And then you can see where the units were, and I'll talk about the last unit here is the one that we did last year. But superimposed on this is also the shoreline as it's retreated over time. So you can see the 1992 shoreline, that bank edge was that far out, and you can see it is migrating landward. The artifacts found at the site include these. These are the bipointed bifaces, and I'm beginning to think that what we had there was probably a cache. Having looked at lots and lots of Paleo-Indian sites on the Eastern Shore, Paleo-Indians didn't discard anything that was big. They utilized it largely to exhaustion, and these have plenty of use life left to them. And what I think we have here are a couple displaced caches, and I'll talk about that in a minute, that may have eroded out and been scattered along the landscape. We did do blood residue analysis. I don't put too much faith in it, but we did it. And this bigger one here, which is, I'm holding a cast of it here, had positive reaction to camelid. The smaller one that I showed you earlier had bovid. They didn't have rat and guinea pig. They had bovid and camelid. But more importantly, there are some Pleistocene vertebrate remains there. We have large-headed llama, bison. The pH there is about 4.8, so bone preservation is not that good, but you can find some teeth. This is Botherium bumbifrons. So we did find woodland muskox and giant bison. So maybe they're contemporaneous. We haven't tried to date these things, and these could be much older than the actual archaeological remains. Some of the bifaces there were either accidentally broken or intentionally broken and resalvaged. The resalvaged ones were the ones on the right. The broken ones are on the left-hand side here. And basically, you can see where they have, kind of sort of salvaged fragments of those things. And here's where they look like they're breaking them, smashing them into like pie wedge sections. This one's got two detachments. Either they're using like a burin or they're trying to get microblade looking flake-like things off of it. I don't know. Here's another pie wedge section where they literally utilize that those fragmented edges to death. You can see all the utilization scars on them. We also found some lancelets. These are the small lancelets to the left, and they cluster in this area here. The salvaged bifaces, which may have been bipointed bifaces that they salvaged, they are way off on the side. Some of the other artifacts that we found there were these objects here. These are, just to give you perspective, this is one here. This is a cast of it. And these are blade-like flakes or blade flakes. They show an intentional shoulder. You can see the shoulder on the side. They are completely unifacial. Occasionally you'll see a little bit of use wear or even marginal retouch. You can see the orientation of the platform is different on some, but we have several of these. You know, is that a tool type, or is it a link to something to the old world? You know, show it to 50 lithic technologists and they'll probably come up with 50 different stories. We did use wear on these things. This is the Marvin K did the use wear. These things are being used as both points and knives. We found cores, some bigger, some smaller. These are your polyhedral-like blade cores. They show aeolian polish or in silica glaze. You can see, based on the orientation here, some of their heads have been stuck up out of the ground for some protracted period of time and pelted by very fine sand. Presumably, this is what happened. The core was buried, and then the surface was truncated, and then aeolian polish to one part of the artifact, and the other artifact, a portion of the artifact, was not aeolian polished. Here's some additional cores. This one here on the left looks like a segment of a big, thick, clunky biface that they're doing bidirectional detachments. You can look at Kostenki and you can find exact duplicates of that. Not to say that there's a correlation. You can go to Kostenki and find it, but you know, there's a template there. Whether it's learned or independent invention, you know, everybody will debate that. Here's another core on the right. Again, it's bidirectional. Blades and or utilized blade-like flakes. Some of them are complete. Some of them show cobble cortex. Some are made out of petrified wood, which occurs locally, believe it or not. Some are quartzite, and you can see that they're breaking the blades and snapping segments. Portions of them are made into scrapers or point/scrapers. That's the one on the lower right. Here are some examples here. This one here clearly derived from a secondary cobble. It shows extensive utilization along one edge, and then the one on the right is a crested or keeled blade, which would have been derived from something on one of those thick bifacial cores, like that the one that I said looked like the ones from Kostenki. So ultimately, this is what we have now. We have sort of a very detailed map of what I call a low visibility site. In 7 years, we found less than 300 lithic artifacts. So that to me is a low visibility site. It's not like the site on the east side of Mockhorn Island that produced 758 diagnostic projectile points in 2.5 hours. This is very low visibility site. But we now know where how shoreline erosion is displacing that stuff. You typically see it transgress with the shoreline and move along the shoreline. And then this is sort of the compendium of our radiometric and OSL dates to date. If you take the OSL results above, you've got moisture content changes immediate above, and you've got some dates that predate the underlying radiocarbon dates. However, if you look at the OSL dates in the more dry sequence of the site, they tend to fall into sequence, and moisture content does affect OSL ages, and Jim Feathers applied one moisture content to the sequence, which you really can't do because you can look and see that the moisture changes from top to bottom. But more importantly, we do have our first OSL date for our younger dry sluice. It's 12,800 plus or minus 1,000 OSL years. That's a pretty good, I guess. We also have dates for our surfaces further to the south, our multiple stratified paleosols. So what about those sites or those multiple stratified paleosols? And what can we learn about the environment? The 4AB1, which dates roughly between 20 and say 22, we have Douglas fir. We have vitrified charcoal, which indicates either high temperature burning or greenwood burning. The phytoliths from the 4AB1, this is the surface that has the artifacts. We have a dominant C3 grasses, cold adapted grasses. We have canary grass as well, looking at the phytoliths. The pollen for the archaeological level, we have cedar, alder, and upland herbs. Go a little bit deeper in our 4AB2, which dates to between 29 and 32,000 years old. Which it would be immediately, if you look at the Northern Hemisphere climate record, it would be a couple thousand, maybe 3,000 years older than the initial onset of maximum cold, which was around 27.5. The 4AB2, we have spruce, vaccinium, again, vitrified charcoal. Phytoliths, we show a mixture of both C3 and C4 grasses, so it's not fully cold. There's a lot of grass phytoliths there. And it would indicate something close proximity to a wetland margin or bog. Go look at the pollen. We have, for our 4AB2, we have giant ragweed, which you wouldn't think of, but clearly that's telling you something that's not that harsh of a climate. We have pine, cedar, speckled alder. Go a little bit deeper in our 35,000-year-old surface. So we're clearly in marine oxygen isotope stage 3. We have spruce, Douglas fir. We have, again, vitrified charcoal. This is the macro plant ID. Phytoliths, we have more C4 grasses, a little bit of C3 grasses. So there's some grass diversity perceived there. The pollen, we have pine, alder, poplar, birch, hop hornbeam, hazelnut. Again, very kind of classic. You could probably go to the Middle Atlantic and find some examples like this today, so you don't have to go too far. And then get to our 42,000-year-old surface, or 41 and some change. We have spruce. Again, we have vitrified charcoal. We did have panic grass present in our plant macro ID. Dominant C4 grasses, the highest that we had seen anywhere, again, would suggest warmer conditions. And if you look at the Northern Hemisphere climate record, that correlates beautifully with a peak warming event that occurred. And there's some indications that you're close to a riparian zone, so the water's nearby. And if you look at you look at the local sea level record, sea levels were probably about 100 feet lower than they are today. So there might have been a marine oxygen isotope stage 3, 42,000-year-old estuary just to the west, not too far away. Pollen for that 42,000-year surface, we had pine, spruce, cedar, and green alder. So in 2019, the Maryland Historical Trust has a non-capital grant program. I figured, okay, it's about time we write up the 7 years of research that we did out there and put it in a coherent whole, and also, more importantly, do some testing. And that's exactly what we did. There are 4 sites on the island, and there's one historic site, and then there's 2 other. The one up here is a drowned late archaic site. It's beneath tidal marsh peat. This one here is a little site that probably washed away years ago. And then the historic site's right here. That's a well. And then I got a student at the University of Delaware, Nichelle Bradley Lewis, interested, and she was going to do GPR investigations, LIDAR, and of the island to see whether GPR can detect some anomalies or detect this buried surface across space. She completed her draft thesis just about a week ago. Here we are dragging the sled, or actually I'm taking the picture. I take a break, dragging the sled. Unfortunately for us, last January, not this past January, but the January before, along the bank profile, an artifact came out. This is another one of those buy points. It's right at the contact between the 4AB1 and the overlying 3CGB2. It shows some aeolian polish on the surface of it on one side. On the downside, it's not aeolian polish. And then last March, The first of the four horsemen of the apocalypse showed, and that's with the presence of COVID, which ultimately everything that we had planned went down the drain. And we were going to have lots of volunteers, lots of help, lots of this, that, there, and the other, and basically that ended quickly. Uh, in mid-March, there was still some interest. Again, everybody had said stay 6 feet apart and wear masks, and you clearly see that we at the time did not. But we're on an isolated island in the middle of the Chesapeake Bay, and we had to get some work done. This is Joe Clemens. We're getting ready to do the mapping of the island using the LiDAR and the drone. And then April, it got even worse. The Maryland governor said, don't travel anywhere unless you get a letter from your boss. So I wrote myself a letter so I could go out there and finish this stuff up. And you can't get any more isolated than a 68-acre island out in the middle of the Chesapeake Bay. And this is a friend of mine, Norm Brady, who helped immensely throughout the whole process. We did a controlled surface collection of the field and found nothing. And then by May, we started excavating, and then I had some of my boys come out. Boys like to dig in dirt, so I said, hey, how would you like to screen dirt? So they went at it. And then early in June, Michelle and Mike O'Neill showed up again, so we were able to progress even further. And then I had some friends and some family come out. Basically, at the start of this set, I said, you know what, I never want to dig in loose ever again. And now finally I'm going to have help to work on this stuff. And lo and behold, the COVID situation made me eat my words. I had to excavate this thing all by myself along with my sons and friends. So we had a good time. You can see we're getting deeper in our sequence. This was a very hot day. I mean, a very hot day. And you can tell I'm having a ball in a a very hot unit, 98-degree temperatures and biting flies. However, on that day, we finally hit the pay dirt. We got down to our deeper layer and we found 3 artifacts in situ. They're still in situ right out there. We backfilled the units with the intention of coming back and doing 3-dimensional mapping of these things. But there's clearly a burinated edge. It looks like a flake, a little chert flake, and then a humdinger of a jasper blade. So this is our unit. Our methodology was pretty obvious. We found the in situ biface there in January along the shoreline, got the positions and said, hey, let's step back in, put our units. We did 4 singular 1 meter by 1 meter units. And you can see the particle size and then the graphics of the soil prization there. And then the weirdest thing ever appeared in the bank profile in October as the shoreline continued to erode just to the south of where we excavated, and a rock feature that I have never seen anything like this before. This is a flat slab of sort of sedimentary rock perched on top of 3 rounded pieces of metamorphic rock, almost like this, a little table. And you know, it's aeolian material beneath, aeolian material above. What this thing is, I have no idea. But I doubt mammoths and mastodons put this there, or even bison latifrons. So anyhow, there are a lot more questions there at Parsons Island. So how old are the artifacts? None of the dates that we got are actually on cultural charcoal. It's environmental charcoal. So you sit there and you go, okay, how conservative can I be? If you accept the OSL dates, the material that's immediately beneath our YD Lewis, and we know that fairly evident, the date on the OSL date is 17,004 plus or minus 2,270 years. That's a big standard deviation, but let's subtract that and make it greater than or equal to 15,130. If you look at our radiometric date, our youngest radiometric date, it's around 20,700. And if you add that to it, you basically end up with around 21,000 years. So we could say that the culture material is bracketed by somewhere between, say, 15,000 and say 21,000. If you want to be conservative, you could say 15 and 20. Thus, we don't have any horrors, we don't have any pits, we don't have anything. And there was no charcoal with that rock feature. So right now, this is all I can say. It's a 6,000 year period. That's a big time period. Don't get me wrong. But even if you take the youngest, it still predates 13,000. If you want to reconstruct the landscape through time, this is the reason why we got excited as we're coming into that shoreline. You could see that buried A horizon, which I actually delineated in the picture in the top three. You can see the old paleotopography, and that was a dune to the north, a dune to the south, a little swale in between, and farther to the south was an interdunal pond. So if you go back through time and you look at Parsons Island, say around 20,000 years ago, it probably looked like the image down below. A dunal material that had somewhat stabilized out, or ailing material that stabilized out. You got an interdunal pond or a swale. Sometime after that, the landscape became destabilized. And then presumably those interdunal ponds or swales either dried up or got buried by Aeolian sand. This would have been the period of time when some of those artifacts got displaced, as indicated by the patterning that we've seen and the Aeolian polish that we've seen on some. So are there any other sites in the region associated with this time frame? We've got Cactus Hill, which you probably read about or heard about. If you look at the dates for their pre-Clovis levels, which has blades and little lancelets, they don't have bite points, but they do overlap somewhat. Another site found by a CRM firm near Patuxent Naval Air Force Base has 2 meters of Aeolian material over top another Aeolian package with a buried surface, and there's a rock in it. And that rock has been beat to death on all ends, as you can see in the picture. I wasn't there, somebody else did this. And they ran a radiometric date on associated charcoal. The associated age calibrates to 18,239 plus or minus 243 years BP. The folks that did this work recommended follow-up work, and the naval archaeologist said nope. So guess what? There could be some amazing stuff there, but nobody will never know. Brief summary. This is my cascade of just so stories. A lot of folks have different ideas of where people came from. You know, whether they came from the North Atlantic or came from Siberia. This is my cascade of just so stories. And again, that's all it is. Linking the context of Parsons Island or anything at Chesapeake to fields like Siberia or Europe or whatever is a big leap of faith. So this is my big leap of faith. This is your idealized profile of the Northern Hemisphere 24,000 years ago. Were there people in Alaska at this time? There's some very equivocal evidence. Bluefish Caves supposedly has cut bone and a few stone tools that may have worked down from above. The dates are around 24,000 years old. So there could be some. Burial Lake, where they found human biomarkers or fecal sterols, and the sediments dated sometime between 34 and 16. So that's, again, equivocal. It's not a nail on a coffin. It's suggestive. So what about this logjam? A lot of people have referred to that the coalescence of the Laurentide and the Cordilleran was an impediment, and people couldn't get through it. And I know a little bit about glacial geomorphology, studying under my advisor was a glacial geomorphologist that worked on the Cordilleran. The Cordilleran and the Laurentide are out of sync. The Laurentide reaches its maximum, say, about 21,000 years ago, and the Cordilleran didn't reach its maximum until about 16 or even 15,000 years ago. So the Laurentide had been retreating when the Cordilleran was further in, stuck into the Cascades. So was this really a logjam, or has the ice moving back and forth obliterated that evidence? I'm going to take you to a site, actually, it's independent of Maine, Natural Trap Cave, Wyoming. What evidence do we have that these two ice sheets were not a barrier, say 24,000 years ago? And there might have been episodic gaps. And Natural Trap Cave is right there. And Natural Trap Cave, lots of animals fall in a hole. And the researchers have been looking at the canids there. And in that the sample, they found evidence that the earlier presence of dire wolf, which is basically a fox on steroids, was replaced by the Beringian wolf. A Beringian wolf was supposedly isolated to Alaska, Siberia, and parts of Eurasia. And its appearance in the lower 48 was impeded by these two ice sheets. But when does it first appear in Natural Trap Cave? 25,800 years ago. And what that would mean, and this is a map from their publication, and they say this, is that clearly the Laurentide and the Cordilleran was not an impediment to four-legged predators like the Beringian wolf. And I add to that, if the four-legged predator can make it through a 1,500-mile corridor, if humans were there, the two-legged predator could make it down south there as well. What other connections? Malta, 24,000-year-old burial near Lake Baikal. You have the burial here on the right. You have the genetic connection that says that 30% of the ancestry of Native Americans is shared by this individual. If you look at the ivory carvings that were associated with that, they include geometrics and beads and whatever else. But note that they did not carve woolly mammoths, and they did not carve woolly rhinoceroses. What did they carve? They carved waterfowl, tundra swan. And I can tell you their B&D, Stu Fidel, who wrote the article Quacks in the Ice, said, couldn't that be a Canadian goose? I said, no, that's a tundra swan in defense mode. Canadian geese, when they get in defense mode, they drop that neck down real close to the ground. And so maybe, like he had alluded to, is that the early colonizers of the Americas were interested in waterfowl, like the tundra swan. And what do you find in Alaska at some of the earlier sites? In Alaska, Swan Point broken mammoth. 30 to 40% of the diet based on the refuse there consists of waterfowl, including swans. So now we're going to get to my just so story. There are two nesting areas of tundra swan. There are those that are on the Aleutians and in the Bering Sea, and those that nest north of the Brooks Range. And the U.S. Fish and Wildlife have tagged these swans, and here's the pattern. The ones that are in the Bering Sea and in the Aleutians either go around the Laurentide, or what would be the Cordilleran ice sheet boundary, or down along the coast into Washington or California or Oregon. The ones that are north of the Brooks Range, in the area where you have Bluefish Caves and Burial Lake, they migrate along that purple line. And there they are, right off Parsons Island on the day we initiated our initial investigation. Now, if you are in Alaska, say during the LGM in the summer, and you're remotely interested in these animals, what is going to be your canary in the coal mine? Because when these animals, when the young fledge, their direction is going to tell you that it's warm south of those two big blocks of ice, because you're going to see them go in a different direction. And note how their direction and their migration pattern correlate damn well with the boundaries of the Cordilleran and the Laurentide ice sheet. And more importantly, tundra swan north of the Brooks Range along the Arctic Ocean do not go to Texas. They do not go to Florida. They do not go to New Mexico. They go right straight to the Chesapeake Bay. So what other things? Genetics. Depends on who you read. The separation between the ancient Siberian populations and the initial American populations, Native Americans. Some people say 23. I'm fine with that. Our stuff seems to be younger than that. There are other publications that say somewhere between 20 and 15. So why go to the Middle Atlantic? Why go there? And why are there so many sites there? So you've got the tundra swan potentially being the catalyst for getting there, but why are there so many sites? The best analog to this would be these early sites being prevalent on the far margins of their migratory trek. Is look at the distribution of early sites associated with the Arctic small tool tradition. We know that they came from Siberia all the way across northern Alaska into Canada, but where are the earliest Arctic small tool tradition sites most prevalent? On the far fringes of their migratory path, that is Greenland, the final end where it terminates. Not Siberia and not Alaska, on the far end. So maybe that's what you're seeing there. So that's my just so story. So time and time again, I've been reminded by some professional archaeologists that you can't learn a thing from eroding archaeological sites. Our collective investigations at Parsons Island over the past 7 years tells you can learn something. Coastal erosion is a double-edged sword. It exposes stuff that you would normally see, but it also destroys that. So you have to be reactive. And hopefully the collective investigations will offer cultural resource managers, academicians, a better understanding of the dynamic nature of archaeological sites impacted by wave and tidal actions. You'd be amazed the number of really cool sites that I'm on. And today, what about the peopling of the New World? Your guess is as good as mine. And ultimately, these are acknowledgments. You can see the cover of the article or the manuscript I finished for the state of Maryland. And more importantly, you can see Art Speece at Parsons Island on October 29th, 2014. So I figured